Hi guys, today we're going to be building a set of solar panels, a line of solar panels. I do not have a vast information about the topic, so I'm going to be visiting the nearest solar panel factory, I guess, to have a more thorough idea of what's going on. Okay, so if we're going to be doing it with glass, you're gonna need. So, okay, this is the glass layer. This is glass. And this is Ava. I'm going to be showing you the materials. These are the panel, the solar cells, and again, Ava, and a special material called backsheet to prevent overheating. So glass, Ava, panel, Ava, backsheet, and glass again. Glass is like this. So glass, Ava, panel, Ava, backsheet, glass. So the reason why we put Ava is to prevent the panels from breaking. But if you're doing it with some kind of plastic, a more home DIY type of style, you don't need to be needing Ava. I'm not going to be using Ava, but I have it to show it to you guys. So okay, let's head to the factory and see how this works. Okay, so we're going to be stepping inside a solar panel factory to see how it works. As you can see, the things are very fragile. They can easily get broken and get modified very easily. So we're going to see how the whole system works and how they can build on without breaking it. So let's see. This is the whole factory. You got two lines of production, one standing right there and the other one right there. So those are two exact same lines of production. As you can see, we're going from the end to the beginning. So this is where the panels are being stuck with Ava and other materials. And this is the assembly part. Because the solar cells are very fragile, a robot is sucking the solar panels and putting them right into it. Most of the panels, if you do it by hand, can get destructed because they're too fragile. This is the last stage of solar panel modification process. This is the final result. Here are the panels stacked right in it. The second set of materials you're going to be needing is a backsheet, which needs to be placed on top of the floor of the solar cells. I mean the back of the cells, and a special material that's used, customized in the solar panels, this is called an Ava. This is actually a brand name for the common type of this material. This is a silicon material, and this is called an Ava. Okay, so the Ava you're going to be using needs to be between the glass and the solar panels so that solar panels don't break. So the order must be Ava, glass, Ava, solar panel, Ava, backsheet, glass. So with this in mind, let's have a look at the finished product. Okay, so we're going to build a solar panel today. So these will be our materials. These are very fragile, so you have to be very careful while while you're handling them. As you can see, I've broken one. When you're taking this with one hand, as you can see, they can be very easily broken, so handle them carefully. Okay, so these are our solar panels. The connection between them should be made like this. The back of a solar panel has these sides. So with the solar panels I brought from the factory are these little let's call them iron strings, iron lines. So you have to solder them just like that, like this, and on top of here. So solder these, and to the second panel, solder this right on top of the panel. Okay. So the electrons out are from the back of the solar panel. When the sunlight hits directly to the surface of the panel, electrons move to the back side of the panel, the solar cell. And with soldering this line, this iron line, from the back of the panel to the front of the second panel, we actually create electricity. We form electricity with sun, with connecting the first cells back to the front of the second cell. So if you would like to connect a series of panels, so that's when things start to get a bit complicated. Okay, so let me just get this piece out of here. So if you like to build a solar panel of 4, you would have to connect them like this. Okay, so this is our 4 cell setup. And after this, okay, so let's assume you've connected the ends of the solar panels correctly, starting from the end to the top. So soldered it right here, flip it off, and solder and continue soldering from the same line. Okay, so let's assume we've finished soldering all of the wires. Okay, so how do we connect 2 sets of solar panels together? How do we do that? Well, let's cut a piece of wire. Let's assume you've finished soldering this line. So what you have to do is connect one end of the solar cell to the other line, but make sure that you connected the correct lines. This line goes with the first line from the third cell, I'm sorry. And this middle one goes exactly like the same. And the last one too. Okay, so if we were to show how this works, it needs to be like this. Okay, take that, and from here. So what we're doing is a huge U shape, with the panels, with the connecting, with wires. So we connect them like this, and this end is going to be the positive, and this end is going to be the negative side of our voltage. Okay, so let's have a look at the finished product now, and I'll explain details later. Okay, so this is how the product should look like at the end. I've done a line of solar cells, not a set, so you can see 4 solar cells with 4 lines with 4 BBs. These are called BBs, with 4 BBs on each one. Let's have the air. The sky is not that much sunny, but anyways, we have to look. As you can see, we have 2 volts of electricity right now. 2.08, 2.07. Yeah. This material is silicon. I used it to cover the solar panels with a special material. I didn't use glass because it was hard to cut the glass piece off at home. So this is just plastic. I found it at home. This is just 2 pieces of plastic with silicon between them. As you can see, the connections start from the front going to the bottom of the second solar panel. So this is crucial. This is the trick. The front of the first solar panel's connection goes to the back of the second one. So this is how it works. Otherwise, it's not going to generate electricity. It's not going to do stuff. I mean, it's just a waste of time. So the normal value for one solar panel is 0.7 volts. So the maximum will be 2.8 volts that we're going to get in a very sunny weather. But since it is not, it's kind of cloudy. So we're getting 2 volts right now, 2.08 volts. But in a sunny weather, you're going to get 2.8 volts at maximum capacity.